right, so everyone is recognizing that we are being recorded. All right. So I'm going to share. All right. So does everyone see the PowerPoint?
Yes.
Yep.
Yep.
Okay. So let's go through this here. So this is an example or a idea that gets us started with explanatory and response variables. So who would like to maybe chime in on this particular question? Pretty straightforward. What is the response variable?
Popular revolution.
Got it. All right. All right. This one too was sort of meant to be a warm up to the rest of the quiz. And of course, if we're thinking about midterm grades and final grades, you would think that they would fall together, right? So what plot do you think that might best be fitted?
Plot A.
Plot A, all right. Now, let's make sure everybody chimes in, participates. All right, so plot A. All right. So for which of the following situations would it be appropriate to calculate the correlation coefficient?
I can go if no one else has it.
A.
Okay, and why is A the one that is most appropriate?
Because the more you study for exam, it's not like causation that you're going to do better. It's just like kind of a correlation.
Okay, that's a good insight. Anybody else have a comment here?
There are two quantitative variables.
Okay, so they are two quantitative variables, and B, C, and D have one or more of a categorical data. So that's why it's appropriate for the correlation coefficient. All right. What is the false statement here regarding the correlation coefficient?
C.
Okay. And why is that, Sebastian? I think. Is that Sebastian or Ryan?
It was Ryan.
Yep.
R has no units.
R has no units at all. That's right. Okay. Now we can stop and talk about these things if anybody has some questions. All right. This true too is probably kind of on the easier side. So we're looking at a correlation, and these are correlation values.
C, because it's positive, but not that strong of a correlation.
I think you're actually right, and I'm surprised at 0.63, but I guess some of this, these dots here and here are sort of influencing that, but yep, it's C. All right. How about this one right here?
It's A.
Okay, why do you say A?
It's extremely positive and they're very close together, so it's very close to 1.
Okay, do you see a curve here?
Yes.
All right, so we probably could get this straightened up through a process that we haven't thought about, but I think it's probably going to be D because it's very curvilinear. So we probably want that to be the answer.
Have we talked about that?
Yep, sure. Go ahead.
No, have we talked about that?
Talk about curvilinear?
Yes.
Oh, yeah. That's right. Okay. All right. How about this one here?
C.
Okay. And why do you say that?
Because even though you're changing the units, the relation between the numbers is going to stay the same.
Especially the correlation coefficient. That's right. All right. What do you think about this one?
False.
False. All right. We can change the axes and the correlation coefficient will not change. All right, on to regression. Back to explanatory and response variables. So what is BFI in this case?
The response variable.
It's got to be the response variable. Okay, so item B is the correct answer. All right, how about this one here? What is the average amount by which BFI changes when triceps thickness increases by 1 millimeter?
D.
Ooh, D. Got that one.
Okay, so what is going on here? What is the triceps thickness? Is that the X values?
Mm-hmm.
So these are the X values, right? These are the Y values. And so what does this here sense? What is this number right here? Or what is this value?
That's the slope.
That's the slope. So in a lot of ways, this question is interpreting what the slope really is. With each 1 millimeter change in the triceps thickening, there's going to be an increase of 0.74 in the BFI. So this is essentially the definition of the slope. All right. Questions? Okay, here is another situation here. Predict the BFI for individuals with triceps thickness of 35 millimeters.
I got C.
You got C?
I did.
Okay, I think that's it. All right. All right. So what is 14.59 in this equation? That's pretty easy. So that's the BFI intercept, or, say again?
Oh, no, you were continuing. I was going to say that I got C.
Yes, that's true. Okay,
Okay.
both of these, A and B, are synonymous. All right. Questions so far? All right. So what would be a correct interpretation of the slope here?
Do you want me to wait or can I go?
Oh, go ahead. Yep, go ahead.
I got A.
All right. And just give us an insight of what you're thinking about that. Isn't this another situation where the definition of a slope is
Yeah, that's how I interpreted it, just as like the question before.
yep, just like the question before.
The only time you'd use the y-intercept is like when you actually see it intercepting, no? I don't know.
Yeah, well, here's the slope right here, right? And this is sort of every time the milligram content, okay, goes up, this is going to go up with the tar content. All right. How about this one here? We're taking points, right? And we're starting to think about how far away these points are from the line. And if we were to call those the squared errors, which one would be? So the square of the point A and B, it's going to be equal to A, all right? Questions? All right. Which one of these always passes through with the regression line?
D.
All right. The average of the X values and the Y values, the average of the Y values. Okay. Closing in on the end. What does the regression line tell you that the correlation does not?
D.
Okay. So this is the predicted value, which is the Y value, and we're going to put something along with X to predict that value. All right. So there's some association between the correlation and the slope of the regression line. What do they share?
C.
Which one? C?
Mm-hmm.
Okay. All right. What do you think? The R squared is telling us something about the variation in the Y values. That is explained by the regression line. This is kind of a similar question. What percent of the variation in the sister's height can be explained by the heights of the brother?
I got B.
Okay, so here's the correlation coefficient, right? We want to square that value and then express it by a percent. So that is B. All right. Question about residuals. Which one has the larger residual?
I got A.
Okay, so B is very close to the line. A is kind of close too, but further away than B. And so we're going to go with A. All right. Any other questions?
Are you going to put the other quiz grades into Moodle?
The other hit,
Like just the ones from when we were at school?
I might have to do that going forward, but you should have a midterm grade, right? Everybody knows their midterm grade,
Mhm.
so that should be a an indicator too. Yep, go ahead, Caitlin.
So I know the midterm grade, but is there, if we want to know like what our grade is with all of the other stuff in, like, well, with this quiz rather, would we be able to email you? Just because like there's some decisions that we have to make this month if we wanted to like pass fail.
Okay. Yep.
Okay, thank you.
Okay, any questions about the homework?
I do. I have one. It's kind of a simple one though.
Okay.
So for the questions that we're asking about the reason why some of like the calculated percentages didn't add up to 100, like what was the reason other than because like you're kind of estimating through rounding?
Right.
I didn't know what to write.
Okay. Let me just go ahead and try to get this on the share. Okay, so I picked out a couple of these. Okay, here's the homework assignment. And I think, Caitlin, you're asking me about some of these things going forward here. And I think I've got, for example, 6.2. I think this comes to adding it up and understanding what is 100%. Is that true?
Yes, no, but there's just some questions, like question 20. I don't know if like they correlate the same too. Yeah, it is this question basically. It just
Yeah.
asks the reason because like for one of them, like marital status, I got 100% for all of them, but then for income, I got like 101%.
Right.
And I didn't know if the only reason I got that was because I just rounded differently. And that would be my reason, but the question just basically asked me to explain like why you might not get 100 every time.
Right. It's basically rounding off error. Okay. And so 99.9 is close enough to 100%, and you could have a little higher than 100%, and that would still be rounded off to that type of error. So I want to go through marginal distributions and conditional distributions. And problem number 20 here gives us a look at what the marginal distributions are. All right, so when we're thinking about this, we might want to think about a single group here, and we're thinking along the lines of the marginal distribution for the marital status. So we have this idea of going from here, this value, the single is the total, okay, of all of the single, whether not even considering income. This is the number that goes along with the single never married. And so if we wanted to know the percent of the single people over all, then we would divide it by the total. And that would be a value of 31.26 for this percentage right here. Okay? And likewise, if we were to start to think about something that is income related, all right? And so if we were to start to think about no income going across here, we would take this value right here and again divide it by the total to get the marginal distribution for no income. Now, if we were to do this, okay, let me go to the next problem here. Questions about this?
No.
Okay. So here would be sort of the idea. We're thinking about back and forth. This value right here, 3.26 is, wait a minute, is this value here divided by this value, and this value here in the blue is going to be this value right here. All right, again, the rounding off error is probably giving us a little bit of a different than 100%. Okay, problem number 21. Okay, so this here, this problem generally is looking at conditional distributions. Okay, so the question, the percent of single men with no income. All right, so what we're asking is we're asked to think about only the single people, okay, the people that make up the single column. Okay, and in this particular case, we want to know the percent of single men and then no income. That's this value right here, but we're going to divide this value right here to the column total that would be associated with single men. And that's what this means as a conditional distribution. All right, so you might think that this sentence right here that we just read is exactly like this sentence here, the percent of men with no income who are single. In this way, we're looking at no income as the issue, the condition. We're going to use this same value here, only we're going to divide it by this value here because we are thinking of men with no income. Does everybody sort of see that?
Yes.
Okay. So that's conditional distribution. All right, so if we were to start to think about this idea, divide entries in the first column, and we're starting to think about the percentages that go along with this column right here. All right, so if we were to think about this, 16.8 43% is this value divided by this one. 24.38 divided by this one here is this value. And yes, if we were to think about this, these four values right in through here, all right, will add up to 100. Does that satisfy your query, Caitlin?
Yes, thank you so much. I was just like really overthinking it, I think.
Yeah, well, it takes a little practice, I'd say. Anybody else? All right. So now I'm going to get to to share with Chapter 8.
Professor Tankersley,
Yes, ma'am.
sorry. I just realized that on my homework, you know what? I'll talk to you after. Okay.
Okay. Yep. Okay. No. Lost my view. Excuse me. Go get rid of these. One more time. All right, so Chapter 8 is where we're going. And here is a sort of a lead in. We're going to be talking about different types of samples, all right? And what we really want to do is we want to know, for example, the sample is coming from a population. And so the sample has to represent the population. So some of the things that could go wrong with sampling bias. It's always a issue when you're thinking about things. Confounding variables are also part of getting an appropriate sample. We're going to be thinking about simple random samples. We want to bring in inferences about the sample to the population. And we'll touch on different sampling designs and a little bit of impact by technology. All right, so these are things that we might have, you know, for example, a sound statistical design is necessary for, you know, all kinds of things. We have to trust the data from a sample, and the conclusions from the sample can be applied to the population, all right? So sampling from large human populations, probably a good sound design, and there's always some kind of practical difficulties. And then, of course, the impact of technology has really helped our ability to use data. All right. So obviously a population is different than a sample. So we want to get a definition. When we start talking about a population, it's the entire group of individuals, okay? All of the individuals in a certain well-defined group makes up the population. And so we want to define that population very carefully so that when we get a sample from that population, it actually represents the population, and that is a critical part of the sample, and it can't be biased by outside forces. So a sampling design is sort of how we express the sampling process and in turning that into something that'll tell us for the population. So we may need a sample survey. We need to sort of identify the what the population is. It's very, very important. Then we want to know how to measure what we feel the issues are. So we have to have measuring tools to do that. All right. Okay, a sample survey. Let's think of this. Does everybody know that the census is going on this year? So here is an idea that is coming from the Bureau of Labor Statistics. And as you can imagine, this is we can sample from this, but this census, this word census indicates that this is a population for which we are sampling. All right, so what do we want to avoid? Well, if we had a sample and we were using, for example, the classmates out of our statistics course, that might be called a convenience sample. Anybody want to think about what convenience sampling is? So
Would it be just like,
go ahead.
if we were doing a sample in our class, the convenience sample would literally be like just sampling our class instead of like going out into the university and getting a more diverse, like broader population size or group?
That's very that's right. Okay, it's easy to do, but it's not going to give us any information. So that's why it is not the best way to sample. Generally speaking, this type of sample is quite biased. For example, if you wanted to know who's using the library and you're taking a sample right at the door of the library because it's convenient, that sample probably is very, very biased in terms of understanding who is using the library. All right, people who take the trouble to respond usually are a certain type of personality, right? Some people like being, filling out surveys, and some people do not. So it may not be the best type of sample without knowing the population. So voluntary sampling, voluntary response sample. Who likes surveys? Do you enjoy when you're called up and you're ready to take a survey?
Sometimes.
Sometimes, right? Well, there are people that want to do it and participate, and other people like myself might not be one of those persons that likes surveys. So it could be a little bit biased too. All right. Anybody want to tell me how to run a simple random sample? Now we get all, go ahead.
You usually take like a population and then you randomize like a certain number of participants to take from that population, and that's the simple random sample.
You need something?
Yeah, that's right. Okay, so you have to, first, you have to have a sort of a pool of people, or maybe a population, okay? And you might use a slips in a hat, or you might use a random digit generator. So random sampling is a really easy or really safe way of getting a sample from a population. So what's really important here is that whatever sample size you have, the individuals that are being chosen from the population, all of those individuals have an equally likely chance of being part of the sample. And if you can guarantee yourself that each person that was part of the sample size came because they were equally likely to have a chance to be picked, then that is a very good way of sampling. So in practice, we can use random numbers generator. A computer, your calculator has that capability too. And then there are tables, and we have tables in our book, and that would be called a random digit table. So let's take a look at something like that. So a random table, random digits table, has obviously 10 different digits from 0 to 9. Each entry is equally likely to occur out of the 10 digits. The entries are independent from each other. That is, one number is not influencing another number. And so we start with this process right here. Give each member of the population a numerical label, and be consistent with using the digits in table B. So let's think about this. So we have 28 hotels, and we want to have a random sample of 4 hotels, all right? So each one of the hotels has a label, a number, okay? And those numbers are 2 digits. And we're going to use the table, the digit row right here, and we're going to start thinking about this number right here, 69. Is 69 part of this, this set of hotels? Nope, I don't see 69. Do I see 0, 5? Well, that's going to be this one right here, Beach Castle. So 69 is out, but Beach Castle is the first selected hotel. And we run our number right down here, 1, and then the next digit would be 6 or 16. And lo and behold, we probably have that one too. This is here, the Radisson is 16. So we'll keep that number too. And we do this going all the way down the row. 48 would be the next, 17 the next, 87 the next. And of course, if we got to 17, that too would be a hotel that we we select. And you go all the way down. We throw out 17 because we've already already used that, and then we get the 4th right here. All right. So those are how we generate a sample using a random digits table. All right. So we'll come back to this. I guess we're going to be coming back on Wednesday, a week from today. Is classes down through Monday? Anybody know?
Yeah.
Can you repeat that?
What's that?
Can you repeat that? I didn't catch it.
Let me see here. Okay, classes are closed through Monday. Okay, so we'll be seeing each other again on Wednesday, a week from today, the 15th. Does everybody hear that?
Mm-hmm.
Yes.
All right. Have a blessed holiday and stay safe. I want to see everybody back on Wednesday.
Thank you, you too.
Thank you very
Happy
much, sir.
Easter.
Thank you.
You, sir.
Have a nice Easter.
Professor Tankersley,
Yes, ma'am.
it's really quick question. I realized while we were like doing questions for the homework that I didn't finish the second part for one of them.
Okay.
Are you grading for correctness now? Because like if you are, like I'll totally like try to figure it out and email it to you. If not,
I'm thinking more about completeness.
because like I interpreted the data, it was like question 23. So like I did all the calculations, but then the second part was like, what do these percentages say? And I guess I like started, but like never finished it.
Okay.
So, I mean, I can like send you like a quick email saying, hey, like this is how I interpreted the data, but I just realized that I didn't finish it on my own.
I'll take it into consideration. Okay. There's no no reason to go out of your way. You've explained it to me, and it's not a big deal.
Okay. Thank you very much.
You have a good day.
Happy Easter.
Happy Easter. Hi, Jill. Hello, Jill.